Okay, I'm back here in the lab, and the last task that I have for myself before I go home today is I'm going to take our cutting sample from the zone saturation here, and eventually what I'm going to do is I'm going to run it through our sieves with a row tap here and do a grain size analysis. But this stuff is fresh from the fields. You can see very, very wet at this point. So in order to run it through the sieves, we use dry sieves. I need to dry this sample off. And I'm going to dry it overnight at 110 degrees. So I'm just going to plop this to a sampling pan. Really, I'm not going to need very much to sieve, so I'm not going to use this whole sample. There we go. See right here. It's our wet sample. Looks like mostly fine to coarse sand, if I had to guess. There's just a little bit of probably fine sand or maybe some silt in there that's giving it just some cohesion. So it's holding together better than if this was just like pure beach sand or something like that. But it's saturated. So into the sample drying oven we go, and I'll be back in 24 hours. And I have to wash my hands yet again. All right, so it's been about 24 hours or so. Let's see, today is Wednesday, so cold front just moved through, a little chilly outside. But let's take a look, see how our sediment sample is doing. It's been in the drying oven about 150 degrees C for 24 hours now, and I can see, yeah, this is definitely dry. So the next step is to take this and we're going to pre-weigh about 20 grams or so, and we're going to run it through this instrument right here, which is called a row tap. Okay, so I've got a tiered weighing boat in here on the scale. I'm just going to take the sediment sample right here from our newly formed well, and I'm just going to pour in about 20 grams or so. That's all I need. All right, so we're at 19.7807 grams. So 19.7807 is our initial starting mass. So I'm going to take this, and next thing I'm going to do, try not to spill any here. Next thing I'm going to do is I'm going to go ahead and load this into the sieve. Okay, so here's our sieves right here, and basically what I have is what's called a nested set of dry sieves. So we have these little, well, sieves here. Each one of these has a grate inside of it with decreasingly smaller and smaller little holes. So what that's going to do is it's going to separate this sediment sample into the different size fractions. So coarse grains will get stuck up at the top, and then finer grains will pass through, and each one will get passed through until we get down to the very bottom. Down here, this one is 63 microns, so you're not going to be able to see the holes there. This is very fine, and by the time you hit this, this 63 microns here, that actually takes you out of the range of sand size. So anything finer than sand would be either silt or clay, or collectively we might refer to those just as mud, and so mud gets trapped into the bottom. Now, there's really no way to sieve for silt and clay size material, so if we have an abundance of silt and clay, there's another method that we can use. Actually, there's two methods that we can use. One involves gravity settling in the hydrometer. That's a pretty long setup, but I'm willing to do it if we find a lot of fines. The other would be to use a pipette and sieve. Both of them are based upon the settling of material inside of a fluid. So we have 63 microns at the bottom, then 125 microns, then 250 microns, then 500 microns, then 1,000 microns or 1 millimeter, and at the top we have 2 millimeters. So all of these have been cleaned. I already looked through them, so they're ready to go. And I'm going to take my sediment sample right here, and I'm just going to pour this into the top. And I can already see a lot of it passing through that 1 millimeter. The stuff that's left, show it to you. The stuff that's left right there, if you can see that, this stuff right here is just basically aggregates, probably a finer material. So as soon as this thing starts going, a lot of those aggregates are going to get busted out. So I'm going to put the top one here. So the next thing I'm going to do is I'm going to take our sediment sample and place them into this setup right here, which allows us to run multiple samples simultaneously. I'm going to pull this out from the top. And I'm going to place this down on the bottom so it doesn't fall apart. Place the sleeve around the outside. Our sample is sample number 2. Going to pop this outer protective layer here. Okay, it's all set up. Last thing, don't forget the lid. This goes on top here. Make sure that this is open for me. Here's our row tap. Feel right here. This thing does 2 things. Does it really well. It's called a row tap. It rotates and it taps on top. So I'll put this final lid. This has a little, kind of like a little press plate on the top of it. And this is where we're going to hammer the top of this, break up all those aggregates. So I'll slide the arm on top. Okay, so that's ready to go. And we're going to set this to 15 minutes. There we go. And I'm going to hit the start button. All right, so it's been 15 minutes. We have successfully rotated and tapped our sediment, and hopefully we've been able to sieve it into the individual size fraction. So I'm going to take it out now. Careful not to drop it, although we could always rerun it. We have plenty of sample left. And we are at number 2. Careful. There we go. Sleeve comes off. Here we go. Our nicely sieved sample. You can see those aggregates that were up on the top. The 2 millimeter, which is really coarse if you think about it, 2 millimeter grain, number 10 sieve, 0.078 inches. There's nothing left there. So all the aggregates have been broken up. All this is sieved through. So what I'm going to do is the next step. I'm going to take each one of these sieves. I'm going to take each one of these sieves. I'm going to take it over to the scale there, and I'm going to empty each one of these sieves onto the scale, and we'll figure out how much mass we've collected on each screen here. So it should be pretty interesting. All right, so here we go. I've got all of my sieves ready to go. And I'm just going to use piece of heavy paper here. We're all about recycling, the Earth Sciences Department. I'm not sure if any of you guys have seen this stuff before. I'm sure you have. The dot matrix printer. Obviously no use for us to have dot matrix printer paper here, other than just to use as a nice place to accumulate our sediment. So the way that this is done, really simple. Pull the sieve off, tap, tap, tap. Anything come out? We didn't get a single grain and that large size there. So definitely finer than 2 millimeters, okay? So I'm gonna go ahead and record that because a null result is a result. So at 2 millimeters, we have 0 grams recorded, okay? Next sieve here, 1 millimeter, okay? Now we got a couple of grains. I feel a couple of grains I could hear. Tap, tap. Yeah, some real coarse grains here. There's not a whole lot of them. Probably about, I could actually count them, probably about a dozen or so. So I'm careful not to lose these. Okay. What I'm going to do is I'm just going to fold my paper. I'm going to bring it over to the pre-pared wave oats. And I'm going to dump those grains in there, just like I got them all. I'm going to let this sit, let it level. And we have 0.0413 grams. So this is 1 millimeter size, 0.041. It looks like it's moved a little bit, 0.0412, and it's nice and steady now. I'm going to hit the tear button. I'm not going to worry about emptying that. I'll just re-tear it to 0. It's not a big deal. Move on to our next sieve. Okay, so here we are at 500 microns. So that'd be a half a millimeter, so half of the last size sieve. By the way, each one of these is progressively 1/2 the size of the sieve above. So this one has a lot in there. Maybe see that. Maybe even hear it, I'm not sure. 500 microns, half a millimeter. Just gonna flip this, tap. Get all the grains. Sometimes they get stuck inside the grate. They're the perfect size. You can see that right there. Really a fair amount. Pull this over here. Dump. Looks like I got everything. Close. And we're at 500 microns. Go ahead and write an entry. 0.7612 grams, so 0.7612 grams. So if you remember, we started at almost 20 grams or so it seems like a lot, but that's really not very much in the grand scheme of our sample. So moving on to the next sieve. Half the size of the previous. This is 250 microns. So a 1/4 millimeter. Look at that. We got a lot of sand in here. I'll dump this carefully. Don't want to spill anything. A couple of good taps. All right. We'll tear it out. Ready? Microns. And we're at 6.6223 grams. 6.6223 grams. So about a third of our sample. Okay, move on to the next one. Here I am at 125 microns. Look at that. We got a lot of sand in there. Pour this carefully. Okay. Let me re-tear this. Shouldn't have left the door open. You may not think that this door really matters all that much, but I tell you what, the AC blowing down is enough to affect this 4th decimal place here, which would be, that would be 1/10 of a milligram. So we're getting down very, very precise weights here. So 0.0000, ready to go? Take this sample. Kind of on the fine side of sands. And that's going to be the bulk. This is going to be our largest fraction by far, so 125 microns. We have 10.9456 grams. So more than half of our sample was that one size, okay? So we're getting a little bit finer here. 63 microns. Tear, not as much. Okay, so we're losing the fine end of sand. Okay, got that cleaned off. This is very fine sand. It's almost silt sized. It's just above silt sized. Over here. Okay. And we are down 63 microns here. We are down to 1.1740 grams. So again, we're dropping out. Now, I'm down to the pan here. And in the pan, I can see some really, really fine material. So this is going to be smaller than sand size. More than likely, this is silt. Just kind of get an appearance of it. It has a light color to it. So it's probably just really fine grains of quartz, maybe some feldspar in there. But it doesn't appear to be a clay, which might have a little bit different color. Around here, we get a lot of kaolinite. Could be the color. But nevertheless, I'm going to go ahead and weigh the pan material. I can get a weight. That's about it. It's actually blowing away. A little bit of it is dust. And let's just see. It's less than about 5%, and we can more or less ignore it. Oh yeah, this isn't much at all. So this would be, we call this pan, or less than 63 microns. And we're at 0.1549 grams. So that would be less than 1%. So less than 1% of our sample is finer than fine sand. So less than 1% of our sample is silt and clay. So not enough to warrant us doing some sort of gravity settling, like a hydrometer or a pipette and filter method. So I've got the data ready to go. I'm going to take this data and I'm going to give it to you. I'll tabulate it for you, and I'm going to show you how we can take this data and we can turn it into aquifer-specific properties. Namely, what we're looking at, or what we're looking for, is the hydraulic conductivity. One method we can get the hydraulic conductivity is to use the grain size distribution. That's the whole point of this lab, okay? I've shown you a lot, but really it just comes down to crunching the numbers at the end of the day. I want you guys to get an experience to see what a hydrologist does and to get something away from this, but really the only deliverable that I can ask for that I've thought of is for you to calculate hydraulic conductivity. So I'll see you probably on the computer for the next step. If I don't break my neck.